Good morning. Let's resolve this problem. What we are asked to do is to calculate the currents, the branch currents, the voltage drops, and the power dissipated in the resistors. First thing to do is, I think, to remind you about the current divider. If we have two resistors in parallel, and if we want to calculate the current flowing in these resistors in function of the main current, then we know that the equivalent resistance of this circuit is R1 times R2 over R1 plus R2. We know that the voltage is equal to the equivalent resistance times the main current, and we know that the equivalent resistance is R1 times R2 over R1 plus R2 times I. We also know that I1 is V over R1 and I2 is V over R2. So it means if we replace V by this equation, we have the results, following results. The current I1 in function of the main current and I2 in function of the main current. So we will use this to calculate the current, for example, I3 and I2 knowing R3 prime, the equivalent resistance between these 2 points. And we can calculate also I5 and I4 knowing the equivalent resistance between these 2 points. It means R1 prime. So let's calculate the equivalent resistance now. All the equivalent resistances that we are going to calculate might help us to calculate the branch currents. Okay, let's go. R equivalent, first of all, R5 and R6 are in series. This is first step. Later they are in parallel with R4. This is second step. Later R3 is in series with all of them. This is step 3. Later we have R2 that is in parallel with these resistances. So it means the fourth, step 4, and the last step is we add R1 to calculate the equivalent resistance. So let's calculate the first step. R1 prime is equal to R5 plus R6. Values of the resistances are here, and the generator voltage is 30 volt, so it's R6, so it's 45 plus 15, it's 60 ohms. R2 prime is R1 prime in parallel with R4, it's R1 prime times R4 over R1 prime plus R4. It means that we have 60 times R4, 20 over 80, and this is 15 ohms. R3 prime is R2 prime plus R3 that are in series, so it means it's 15 plus R3, which is 15, give us 30 ohms. R4 prime is R3 prime in parallel with R2. This is R3 prime times R2 over R3 prime plus R2. It means that we have R3 prime 30 times 10 over 40, and this gives us 7.5 ohms. And lately R5 prime, which is equal to the equivalent resistance is R4 prime plus R1, and this is 7.5 plus 7.5, and it's 15 ohms. So now we can calculate the equivalent, the current, the main current is E over 15, so it means it's 30 volt over 15 is 2 amps. Okay, we can write it here to is 2 amp. Okay, let's write as well R1 prime because we might need them. R2 prime is 15 ohms, R3 prime 30 ohm, R4 prime is 7.5 ohms, and the equivalent resistance is 15 ohms. Now we can calculate I3 and I2 using the current divider. So we can write that I2 in function of I1 and I3 in function of I1. This is I2. I2 is R3 prime over R3 prime plus R2. This is R2 over R3 prime plus R2, and is equal R3 prime, it's 30 over 30 plus R2 40 times 2, and here R2 is 10 over 40 times 2, and the value here I2 is 1.5 amp, and I3 is 0.5 amp. Now we can calculate this current that flows here, I5 and I4, using in function of this current, so I4 and I5 using the current divider in function of I3. I4 is equal to R1 prime over R1 prime plus R4, and here is R4 over R1 prime plus R4 times I3, which is equal to 0.5 R1 prime 60 over 60 plus R4, which is 20 times 0.5, and here R4 is 20 over 80 times 0.5. This will give us I4 is equal to 0.375 amp, and this current is equal to 0.125 amps. Let's write them here so not to forget them. I3 is equal to 0.5 amps, I4 is equal to 0.375 amps, and I5 is 0.25. It's point everywhere, I'm sorry, I'm doing it, I'm sorry about it. Okay, let's go. Now we have to calculate the voltage drops in every resistor. This is very easy. So for VR1 is equal to R1 times I1, VR2 is equal to R2 times I2, VR3 is equal to R3 over times I3, VR4 is equal to R4 times I4, VR5 is equal to R5 times I5, and VR6 is equal to R6 times I5, because I5 is equal to I6. Okay, let's calculate all of these voltage drops. 7.5 R1 times 2, this is 15 volts. Here R2 is equal to 10 times I2, which is equal 1.5, it's 15 volts. R3 is equal to 15 times 0.5 I3, so that gives us 7.5 volts. Here R4 is equal to 20 times I4, 0.375, and is equal to 7.5 volts. R5 is equal to 45 times I5, which is equal 0.0 point everywhere, point, 45 times 0.125, and is equal to 5.625 volts. R6 is equal to 15 times 0.125 point is equal is equal to 1.875 volts. And now we can calculate the power dissipated, PR1, PR2, PR3, PR4, PR5, and PR6. This is what VR1 times I1, this is VR2 times I2, this is VR3 times I3, this is VR4 times I4, this is VR5 times I5, this is VR6 times I5, and we can write down all of these. So VR1 is equal to 15 times I1, which is equal to, this is 30 watts. This is VR2, this is 15 times I2, I2 is 1.5, and it will give us 22 times 5 watts. VR3 we calculated here, 7.5 times I3, which is 0.5, and it's 375 watts. And here VR4, 7.5 times I4, 0.375, and is equal to, well, write the results later. VR5, this is 5.6 5.625 times I5, I5 is 0.125, and here it's VR6, 1.875 times 0.125, so I will write the results of this. Okay, here the result is PR4 is equal to 2.8125 watts. Here it's 0.7 watts, and here it's 0.234 watts. We can calculate the main power delivered by the generator. Total P is equal to E times I1, and this is 30 times 2, and this is 60 watts. And remember that total P is equal to PR1 plus PR2 plus PR6. It means that this should be equal to the sum of these 6 powers dissipated in all the resistors. And thank you very much.